Numbers were born from the dirt. The earliest humans needed to count things that actually existed. 1 sheep, 2 days of travel, 3 arrows. It makes perfect sense to invent a symbol for something you can hold in your hand. But how do you invent a symbol for something that isn't there? For the first few thousand years of human mathematics, the concept of zero simply didn't exist. There was no number for nothing. However, the absence of zero created a mathematical nightmare. This is the story of how humanity finally stared into the void, named it, and unlocked the foundational secret of modern science. Travel back to ancient Babylon, around 300 BC. They wrote on clay tablets using a stylus that left wedge-shaped marks. Their system was base 60. They didn't have a zero, they just left a physical gap. If you wrote a 1, left a space, and wrote another 1, did that mean 61 or 3601? It depended entirely on context. To avoid disastrous calculation errors, scribes eventually began inserting 2 slanted wedges to act as a spacer. It wasn't a number. It was just a punctuation mark meaning, pay attention to the gap. Half a world away and entirely independently, the ancient Mayans also encountered the gap problem. Their incredibly advanced astronomical calendars required calculating millions of days. To manage massive base 20 numbers, they invented a symbol representing a turtle or snail shell. Many anthropologists believe it represented an empty container, a shell without a snail. But just like the Babylonians, the Mayan shell was largely used as a calendar placeholder. It was incredibly sophisticated, but it hadn't yet been fully unbound as a standalone number. The true philosophical and mathematical leap happened in India. In Indian spiritual philosophy, the concept of shunyata, or emptiness, was not something to be feared like the European void, but a state of profound clarity. In 628 AD, the astronomer Brahmagupta took this philosophical emptiness and dragged it into the rigid world of mathematics. He wrote down the rules. 5 minus 5 equals 0. This was revolutionary. 0 was no longer just a punctuation mark. It was a number. It could be added, subtracted, and manipulated. It was exactly as real and exactly as mathematically valid as 1 or 2. By defining 0 as a valid destination, Brahmagupta accidentally unlocked the other half of the universe. If you can subtract 5 from 5 to get 0, what happens if you subtract 6? 0 served as a mirror, a hinge point across which the positive numbers could reflect into an infinite, shadowy world of negative numbers. Debt, deficit, below freezing, geometry, and algebra were permanently bridged. René Descartes later used this central 0 as the origin point for the Cartesian coordinate plane, allowing us to map the stars. But treating 0 as a normal number introduced a lethal bug into the logic of mathematics. Multiply 1,000,000 by 0, and it vanishes. It is a black hole, unrecoverable data loss. But division is worse. If you ask 12 divided by 3, you are asking, how many 3's fit into 12? 4. But if you ask 12 divided by 0, how many nothings fit into a something? An infinite number of them. As you divide by smaller and smaller decimals, the result explodes upwards. If you divide by 0, the graph shoots up asymptomatically toward infinity, breaking the system. In programming, dividing by 0 crashes the software. How do you handle a curve that refuses to sit still? Fast forward to the 16th century. Newton and Leibniz wanted to find the exact speed of a falling apple at a frozen instant in time. To calculate speed, you need 2 points, distance over time. At a frozen instant, the time passed is 0. The distance passed is 0. 0 divided by 0 is mathematically illegal. It's a paradox. Their genius was to never actually touch 0. They used limits to slide the 2 points infinitely close to each other, shrinking the gap toward 0, revealing the tangent line. Calculus was born by surfing the edge of nothingness. In the mid-20th century, 0 underwent its ultimate transformation. When Claude Shannon developed Boolean algebra for electrical circuits, He realized that all logical statements could be mapped to just two states. A single tiny transistor switch in your computer. When electricity flows through, the computer reads a 1. When the current is broken and stopped, it reads a 0. By arranging billions of these ones and zeros in complex logic gates, and gates, or gates, XOR gates, we can calculate literally anything. A universe of meaning constructed entirely out of somethings and nothings. Every pixel on your screen, every digital photograph ever taken, every text message, every frame of this video, they are all just sequences encoded in base 2. Even artificial intelligence, the pinnacle of modern computing, relies on this foundational math of 0. Neural networks are just vast arrays of nodes passing ones and zeros, multiplying weights. When a network learns to ignore irrelevant data, it effectively multiplies those connections by 0, dropping them out. The void continues to act as the ultimate filter of truth. From a confusing gap on a clay tablet to philosophical emptiness to the foundation of digital computation, 0 is not just a number. It is the canvas upon which the entire universe is calculated. The next time you see a 0, respect it. It took humanity thousands of years to understand that a circle of nothing contains quite literally everything.